Let's run some calculations now inside of the BIM model of our building that we have also calculated on our Google Docs spreadsheet, and that way we'll be able to compare the two. So I'm going to go ahead to heating and cooling loads under Analyze, and I want to set it up. I've got it set for a single family for Alfred, New York. You can pick a new location by just searching using the map. In this case, I picked the closest station to our location. The ground plane, none of these need adjustment. We need to pay particular attention though to two things down here. The tightness of our building, it could be set to none, so it's not losing any air. And then the report type, let's at least make it a standard one. We'll save those settings. And what we need to do in order to be able to calculate is I'm going to go to level 1 and I'm going to define a space for it to work with. So I just went to the space tool and clicked that. I did that a little fast. Let me go backwards. So I went to level 1, selected the space tool, and clicked and selected that. Now we can also zone those off so we could have spaces within spaces. But now if I click on heating and cooling load, you'll notice that there's a surface inside that's highlighted. And if I went to the building model and opened it up, I can see these are a couple of other spaces I've done going through this experiment, and they're not being used. So there's our space for our building, and discusses how many, the lighting load and a couple of other pieces of detail. Anyway, we're ready to calculate. So I'll click calculate, and it quickly generates an output. You can read through it. It's about it's our 20 by 20, but you can see there's a net area of internal space and that corresponding volume. So we had 404,000 for ours. It's a little bit smaller because the walls are taking up space. But most importantly, if you go all the way down to the bottom, you'll notice the final calculations here. We have a heating load of 4,800 BTU. And if we were to look at our spreadsheet, we calculated 6,000. So we're off about, actually we're about 6,100 and this is 4,800. So we've got a little bit of discrepancy in our calculations, and we can compare those back and forth. The other thing is we can make some minor changes here and just make another run. So we have, let's say we change the tightness of our building a little bit. We made it loose and calculate it. Let's take a look what happens, and our calculations go up. So what I'm going to do right now is I'm going to take a screenshot of this, a snippet, so we can take this value and I'll save it as our load calculation. So I'll save it where I have a previous one here. I'll go ahead and save that and replace it. And then what I wanted to do is be able to keep that up on the screen and then bring in our energy calculation that we've done so we can do a little comparing back and forth. So now I just have to get this one to come up front. So here we go. We have our well, I'm not showing it's a wall load is 14,000 BTU. We calculate, or 1,400. It calculates 1,100. Our windows at 18. It calculates at 2,100. Our roof load at 493. It calculates at 338. But all of these numbers are tracking pretty closely. The air infiltration, more in line with what we had calculated. So we're really very close in these kind of numbers, although I fudged it a little bit by changing the infiltration or reducing the infiltration level. Now, it's not to say that everyone would be this accurate, and we might have just lucked out with it, but this is a good indication that our ability to calculate some wall values and then see them come through in Revit are comparable with each other. So the last thing I'd like to do is bring this all together in a final report for the project, and I'll pick that up in the next clip.